This is part 3 of the Mandelbrot series development, where I code a Mandelbrot set with JS, JavaScript, HTML. So, in this one, I'll add zoom functionality. This is the goal of part 3. And in the previous part, I've rendered the whole thing, as you can see here. And this is the code that I have so far. So, with some minor changes in between. So, there's going to be video chapters in which you could follow along. If you have not watched part 2, you may look at it in the link in the description. Otherwise, this is part 3. Enjoy. To get started, I played Valorant over the course, and here's a random clip of the day. Drinking some soda. Okay, I hope you enjoyed it. And now, on to the program. So my goal here is that I am going to add JavaScript code that will change the zoom. And the zoom will depend how far into the set I will zoom. And I'll see more of the details. You can see that this is the Mandelbrot set. And I will add some zooming, so let's do that. First of all, I'm gonna get an event handler to a key press. So I'm going to connect that to a function. I'm going to call it input handler for now. And I'm just going to, for now, I'm going to log the key press, the key code that has been pressed. This is the function that will be called once I press down any key. This will take in an event. And I'm gonna just lock it for now. No, I'm going to, the event is the key that I am. So it's a keyboard event. And I'm trying to get the key value, which is what I wanted to do. So yeah, I got the key, and I am going to now do a switch, because it's whatever key pressed will change one of the zoom factors. So like, let's say zoom, which is a factor that I will change. By the way, zoom is a variable that I've initialized and declared it based off the width of the canvas, and it's the variable that depends on how deeply zoomed this picture is, how zoomed in it will be in terms of rendering. And I change it here in the coordinate. So yeah, I guess that is what I did, because in this convert to coordinate, the x will be divided into a decimal or something. So yeah, pressing R and T, and now I'm trying to create a function that re-renders the thing. So I'm going to get the canvas. I think I did it. No, it was here. I'm going to get a handle of the canvas and re-render it. And I'm going to get the context and then re-render it. I'm not sure if I'll even need it because I have a function already that does it. Maybe I don't even need this because this function has it, so. And I'm going to just log something that draws image. It's already done. So I am going to do something. Maybe here in case R, I'm going to zoom. I'm going to multiply the zoom by 2, which is the multiplier, and then re-render it, or re-render. Maybe if I just call draw full image without re-rendering or something, maybe that I will still be able to do it. Look at that. It's zooming in. This is really cool. You can zoom around. You can zoom in, but you cannot zoom out. So let's do like that. Also, if I try to press an uppercase R or F, it's not gonna work. So let's do it. Oh no, I forgot to do a lowercase function. You know when, uppercase, you know when you get a key and you want to convert it to a lowercase. There should have been like a suggestion, or like in Java there's a string car, you could convert it to a lowercase, but I'll leave that maybe in another time. So if I press T, it's going to zoom out. Let's try zooming it out. I'm not gonna use this function anyways. Maybe I'll use it later on when it comes to validating, but yeah, I'm gonna leave it. I'm gonna just remove it for now and re-render. I'm gonna re-render it every time you zoom in by pressing R or zoom out by pressing T. For zooming out, you just have out the zoom, and I'm gonna try and test that. I am zooming in by pressing R. And I'm zooming out by pressing T. Look at that. I'm zooming out. Alright. It's a string, so I just logged select also as well the type of the key value. And I am going to now do something else. So I've got the zooming functionality. Done. Now the harder thing is I want to get find a way to also pan the image right, left, top, and bottom. So let's try that. That's the next step. So let's try to declare some variables in which I will ban this set. So I made two variables. This is the offset from the center. So imagine the very center of the image as 0, and pan x will change, or I, depending on what key you pressed and the WASD, W-A-S-D. If you press W, the pan x will shift to the left, and D for right to shift to the right. W to shift I upwards, I think, and X will, and A will shift downward. So let's try that. So let's do a rerun, a case of WASD. Some notes here. Pan upward. Pan downward here for A. S is panning to the left, and T is panned to the right. So let's try something. When you pan to the left, what will happen is let's say if you press upward, WAS, if you press if you press A, no, A is leftward, and S is south, downward. I got confused with A and S for some odd reason. A, if you press A, you should pan to the left. So I'm gonna edit this and log something. Pan left, in which you don't multiply zoom, you add on to pan X. You subtract because you're going left. Let's do it 1 for now. I'll have to change it. And if you want to pan to the right, you don't zoom, but you just that. So I pan left, and then I pan right. If I press the A and T keys, pan left, pan right, and I drew the image. So yeah, but now I need to re-render it so the image shifts to the left and to the right. Whoops. And that's what I'll do next. And here, convert to coordinate. This is the function that is in charge of it. So what I'll do is I'll add pan x to see how much it will change. I'll do the same thing for pan I, and let's see. It moves, it shifts. If I press S, A, again, I'm confused. If I press A, it'll move left. If I press D, it'll move right. You see, as I'm pressing S, you can see the login statements. Because not only that I converted to X here, but I added pan X, which is like an offset. And this is called, when you convert to the coordinates, it's in charge. It just shifts. But if I zoom in, like here, you can see that it goes too quickly. Like that, which I don't want. I want pan X to change depending on how zoomed in you are. So, in order to zoom in, in order to fix that, that's what I said about 1 and 1 here. I want to change that so the pan X, the value of pan X doesn't change much when you're zooming in, and then when you zoom out, it changes a lot. So that's the challenge. If you're zoomed in and you want a pan X, you don't want your X offset to change a lot. So let's try setting a variable. Let's do a magnification variable. This is a value that will change depending on in relation to the zoom. So if your zoom is twice, the magnification will be twice as much. Likewise, if your zoom is like half the original, this one will also be halved. So let's not only you multiply zoom, you multiply magnification, where 1 is the starting magnification. Do the same thing for zooming out. You just have the magnification. Divide it. And when you pan to the left, I don't need this console log. I'm going to change by whatever the value is divided by the magnification. So let's say if you don't zoom in and your magnification starts at 1, and so your X value, your X offset, which is the panning, will change by 1. If it's like 2, which is more zoomed in, the value, you'll change pan X by 0.5. It'll become less and less the deeper you're zoomed. So yeah, over magnification, and I'm going to test it again. R for zooming in, and you can see the pan doesn't change as much. You can see that's why the picture doesn't move so fast. And before I explore the Mandelbrot set, I know you viewers are eager to see it. if you want to skip ahead, then there's the video chapters. Also, if you've reached this far, please consider hitting the like button. And yeah, so as I have fixed the panning left and the panning issue, now I'm gonna try panning upwards and downwards. So it's gonna be very similar. Instead of panning X, I'm going to pan I to the I value. If you pan downward, maybe I'll add it. Pan, I'll subtract it over magnification, and pan D will be pan I will be, no, that's panning to the right. Forgot the break. And to pan upward, I'll do add on to 1. So let's test it. So pan left and right. Now if let's try pressing W. It pans downward, which is what I do not want. So pan I think that is basically it adds on. I'm not too sure why if I add pan I, if I add shift, it moves you downward. I've been thinking of this a lot, but I think it has to do with the shift in the y-axis. The vertical shift is different. Like it starts at positive or something. Let me know in the comments what's the full explanation. Why if I try to add to the offset for panning in the y-axis or the I-axis in this case, why does it move downwards if I add it? But if I would subtract upon pressing W and add on when I move downward, if I add it should go up. Oh, I didn't save. Now it works. So if I press W, it goes up. If I press S, it goes down. Likewise, if I zoom in, R and T, R to zoom in, and I tried panning upwards, you can see it doesn't change as much. So yeah. So now, once I have basically done the very basic navigation of this set. I mean, I've got the basics of navigating and zooming in, letting the user zoom in and out, and panning X and right. Now I'm gonna try to explore. I'm gonna show you. I'm gonna explore the Mandelbrot set a little bit. So let's try that. So let's move on. Let's move around. Let's see how much this set has to offer. So you can see there's a big thing. There's a big heart-shaped thing. You can see the full picture. And there's some circles on the side. And if you zoom in here, you can see there's a mini Mandelbrot set. This is a smaller version of the set. And if you zoom in again, you can see that there's another mini Mandelbrot set. Right now, it does not look as appealing, but the thing is that if you increase max iterations, it will resolved better. It will better resolve this section because I don't have a lot of iterations, and if I would increase my max iterations, that means that I'll have to make the computer reiterate more and more, and it's going to slow down the performance. So let's try increasing the max iterations. Let's do 400 iterations instead of 100, so you can see it's much darker. But if I zoom in, it takes a while longer because the computer has to iterate more through the pixels. It's gonna take more time. So you can see there's a mini Mandelbrot set here, and in the other one you can see it's more resolved because I've added more iterations. Isn't this amazing? This is so cool. Pretty nice soda. Pretty delicious. And so if I zoom in here, you can see there's even another fractal here with even more lines. And zooming in here, and there's even another set. Once again, it doesn't look like a Mandelbrot set because it looks more of a triangle, which is because I need more iterations to fully resolve this. But I'm not going too far. So let's zoom out. Let's reset it. And let's move on to, let's explore another part. Let's explore this section. If I go, there's some branches on this side. If you can see, that looks like snowflakes. That looks so cool. And like there's like spirals that go infinitely deep. I'm zooming into one of them. If you could zoom in here, you can see that the spiral will keep going forever and ever. I'm zooming in, inward and inward, inward, more inward, more inward, more inward, more inward, more inward. No, I'm zooming outward. I should zoom inward. My mistake. This spiral essentially goes forever and ever as it wants to. Like I said, the Mandelbrot set is an entire fractal that keeps on going. It's like you're trying to land on, it's like you're in a parachute and you try to land on, there's a ground below you, but the thing is that the ground keeps on going and going, like you cannot touch the ground. That's how I can explain what a fractal is. Infinite zoom, you'll never touch the ground. You'll never hit a ground or anything. Of course, which is the computer. Of course, the computer will not let you zoom in any further at one point because there is a limit to the precision of JavaScript's double floating point. If you reach that, all of the pixels will be inaccurately rendered. You will see blocks. I've tried it before. And as I zoom in more into these spirals, you can see that I'm zooming into one of the arms of the spirals, and each of these arms, there is some even more smaller spirals in which they zoom. You could zoom in infinite amount of times, and along these spirals, I'm zooming into even an arm of the smaller spiral, and these arms are also made of different spirals. You can see over here, and even these arms platforms have also spirals, which is so cool. So, yeah. One thing I'd like to show you is this part. If I zoom in here, there are these little branches that go here, that go around these circles, these smaller circles you can see here and here and here and here. And there's like 1, 2, 3, 4, 5 branches here, including the trunk here. There's 1, 2, 3, 4, 5, 6, 7 pieces, including the trunk. And here is 9. Here is, I guess, 9. 1, 2, 3, 9, including the trunk, and right here, and it keeps going on and on. And this counts the odd numbers, which is so cool. You can see the computer takes time to render this, but look at that. Look how infinite this goes. And I'm not gonna go in too deeper because this thing goes infinitely, and it's gonna take a while for the computer to re-render everything. We are 30 minutes into this video. Well, more than 30 minutes because I made it into recorded sessions, as I've added the zooming part that I allowed the user to zoom in, and I'll zoom in to the left and to the right and to the up and to the down. I'm going to end this part for now. So I hope you enjoyed this video. Let me know in the comments whether you want me to add another part, make another part where I add some functionality to this, more functionality like an input handler or something. Let me know in the comments down below. And of course, if you forgot, if you happen to watch till the end, please drop a like. It will be greatly appreciated. So anyways, this is the end of part 3. See you in another video. Peace out.